Welcome to our channel. In this video, we will learn how to use the law of sines in solving oblique triangles. Let's have a recall about an oblique triangle. Oblique triangle is defined when a certain triangle doesn't have an angle that measures equal to 90 degrees. We have two types of oblique triangles. One is the acute triangle that all angles are less than 90 degrees, and the obtuse triangle has one angle that measures greater than 90 degrees. Capital letter represents the vertices of each triangle, and lowercase letter represent its sides. To solve an oblique triangle, we sometimes require to break them up into right triangles. This is done by drawing a perpendicular line from the vertex of angle C to its opposite side. This is what you call the altitude of the triangle. This cuts an oblique triangle to create two right triangles. The other endpoint of the altitude will be represented by capital letter D. The altitude is now included as one of the side of the created right triangles, so the line segment CD will be represented by small letter h. Using newly formed right triangles in two oblique triangles, we can show that the proof of law of sines exists. Let's begin with the right triangle CAD. We have to apply the sine function to the acute angle A from the right triangle CAD. It gives us sine A is equal to the value of the opposite side of angle A all over the value of the hypotenuse. That is also equal to the value of h all over the value of b. Deriving for the value of h, we have h is equal to b times the value of sine A. Next, analyze the right triangle CBD. We have to apply sine function to the acute angle B from the right triangle CBD. It gives us sine B is equal to the value of the opposite side of angle B all over the hypotenuse. That is also equal to the value of h all over the value of A. Deriving for the value of h, now we have h is equal to A times the value of sine B. Equating the values of h, it gives us A sine B is equal to B sine A. Multiply both sides of the equation with 1 over sine B times sine A. It gives the result of A all over sine A is equal to B all over sine B. We create another altitude that starts from the vertex of the angle A and have another set of right triangles. We have right triangle CAE and right triangle BAE. Doing the same process of calculations, we can prove that B all over sine B is also equal to C all over sine C. Combining A all over sine A is equal to B all over sine B, and B all over sine B is equal to C all over sine C, will turns out to be the formula of law of sines. And now we have this formula, A all over sine A is equal to B all over sine B is also equal to C all over sine C. At this point in time, instead of breaking up oblique triangles into right triangles, we can use this formula of law of sines to solve for the missing sides and angle of an oblique triangle. Case 1. Two angles and a side are given. Let's say that the value of the angle C is equal to 60 degrees. And the value of angle A is equal to 40 degrees. The value of the side A is equal to 40. Find the missing value of angle B, side B and side C. We solve for the value of angle B. Adding all angles of a certain triangle is always equal to 180 degrees. Now, all we have to do is subtract 180 degrees to the sum of the values of angle A and angle C to obtain the value for angle B. Plug in all the given values to the formula. Simplify the equation. Angle B is equal to 180 degrees minus 100 degrees. Subtract 180 degrees and 100 degrees. Now we have angle B is equal to 80 degrees. Next, find the value of side B. Use the formula of law of sines. That is, A all over sine A is equal to B all over sine B is also equal to C all over sine C. Analyzing the given oblique triangle, sine A and side A have existing values. Therefore, we can use this A all over sine A to pair with B all over sine B. We use b all over sine b is equal to a all over sine a to make a formula for side b. Multiply sine b to both sides of the equation. It gives us b is equal to a times sine b all over sine a. Plug in all the given values to the formula. B is equal to 40 times sine 80 degrees all over sine 40 degrees. That is also equal to b is equal to 40 times 0.9848 all over 0.6428. After simplifying the equation, now we have the value for side b, and it is equal to 61.28. Or b is equal to 61. We have to solve the value of side c. Use the formula of law of sines. Since the value of side b, angle b, side a, and angle a are available, you can choose either of each set. I choose a all over sine a to pair with c all over sine c. Then we use c all over sine c is equal to a all over sine a to make a formula for side c. Multiply sine c to both sides of the equation. It gives us c is equal to a times sine c all over sine a. Plug in all the given values to the formula. C is equal to 40 times sine 60 degrees all over sine 40 degrees, which is also equal to 40 times 0.866 all over 0.6428. After simplifying the equation, it gives us the value of c is equal to 53.89. Or c is equal to 54. Case 2. Two sides and the angle opposite one of them are given. Consider the triangle that has side A equal to 40. The value of side C is equal to 54. The value of the angle A that is opposite to the side A is equal to 40 degrees. We solve for the value of angle C. Use the formula of law of sines. Since the value of side A and angle A are visible, then we can pair it with C all over sine C. So we use C all over sine C is equal to a all over sine A to make a formula for sine C. Multiply 1 all over c to both sides of the equations. It gives us 1 all over sine C is equal to a all over c times sine A. Get the reciprocal of the equation. Sine C is equal to c times sine A all over a. Plug in all the given values to the formula. Sine C is equal to 54 times sine 40 degrees all over 40. Is also equal to 54 times 0.6428 all over 40. After simplifying the equation, it gives us the value of sine C is equal to 0.86778. Converting it to degrees, we have to use the inverse sine function. Inverse sine of 0.86778 is equal to 60.2 degrees. Or 60 degrees. Now that we have the value of the angle C, which is 60 degrees, then we can easily find the value for the angle B. As what we did earlier, we just subtract 180 degrees to the sum of the values of the two angles. There you go. After simplifying the equations, we have angle B is still equal to 80 degrees. We solve the value for side B. Two sets like angle A, side A, and angle C, side C, have existing values. I choose A all over sine A to pair with B all over sine B. So we use B all over sine B is equal to A all over sine A to make a formula for side B. Multiply sine B to both sides of the equation. It gives us B is equal to A times sine B all over sine A. Plug in all the given values to the formula. B is equal to 40 times sine 80 degrees all over sine 40 degrees. Is also equal to 40 times 0.9848 all over 0.6428. After simplifying the equation, it gives us the value of side B is equal to 61.28. Or the value of side B is equal to 61. There are other special cases in oblique triangles that should be solved using other law in trigonometry. Oblique triangle has two sides and an angle that is not opposite of one of them. Oblique triangle has only three sides given. It will be presented in our next video. That's all for today. Please like, share, and subscribe. The YT University.